right, the boss says we need to start.
If everyone can just make sure to sign in so that I can get you these 2 credits, but other than that, like,
And then I totally understand if you get text or something, because a lot of you are expediters and you got to answer. Just I would ask that you turn the ringer off. I need to do that too when I do these seminars, so I totally understand. I'm Mike Coelho with Coelho & Associates. We're a poured concrete contractor in southeastern Wisconsin. Brief history, because it's boring. I do have my finance degree in '92. I had been working for my dad for about 6 years prior to that, every summer. That's how I put myself through college. At that point, I had a decision to make. My degree was in finance. I had a friend that owned a bank. I met with them, said, you know what, I like being outside and working outside. So I went to work with my dad. And at that time, what he did was garage slabs, footings, and basement floors, garage floors. However, his training was in block foundations. And we were sitting across the street doing a footing. Guy across the way did a poured wall. We said, hey, you know what? That's the way to do it. So that's how we got started. 97, a couple of our builders said, hey, you need to be a member of the MBA, which is probably the smartest thing I did. And they got me involved in the arbitration committee. At that time, I also joined the UDC committee, and then soon became chairman, co-chair of the UDC committee. That led to me being selected by Governor Doyle first, and now subsequently Governor Walker, to be a member of the Single-Family, Two-Family Code Council. And the last 4 years, I've been the chairman of that committee. So that is my background. We do about, at one point, 2005, I think we did 700 foundations that year. Now we're probably around 350 foundations a year. The foundations in 2005 were probably half the size of the ones we're doing now, and you probably have seen that trend, so it's hard to compare, but that's where that is. So what we're going to go through, the Uniform Dwelling Code for foundations is a pretty sparse, I think it's 3 pages long, is all it covers. And the reason that it's very short is the code actually, through reference, pulls in other codes, so they're international codes. So they reference for masonry, it's ACI 530. For structural concrete, it's ACI 318. And for residential concrete, it's ACI 332. So some of the stuff that I'll be talking about today will be out of those sections. And those are the things that are little known to the most of the world, because those publications cost a lot of money, and then to keep up with it, because it's constantly changing, it is difficult. So a lot of building inspectors, they don't have access to this information. They've been trained a certain way, and you'll find out when you go to different municipalities, one will pick on something, and it's because they have knowledge within those industries. So we'll go through some of that. The 3 primary functions of the foundation is, number 1, carry the loads from the roof trusses all the way down to the soil. Number 2, keep out the bulk water. And number 3 is keep the backfill soil pressure from pushing in the foundation. So it has to do 3 things at one time, and that makes it a little more difficult, and you have to understand your plans when you're kind of analyzing those things. First thing to be able to do that is to understand soils. So we're going to go over that a little bit. Concrete and steel and what those properties are between them. They should be, you should always have one with the other, not without. Okay? The code doesn't necessarily require steel, but as far as the state code, but if you go into ACI 318 and 332, it is very important, and if you talk to any engineer, it's even more important. Okay? And then something that has come up more, especially because we're coming out of winter, and I want to just touch on it because it seems like it's misunderstood, is the significance of time and temperature with concrete strength. I see a lot of people backfilling early, or meaning early because it's too cold and the concrete hasn't attained enough strength and they are unaware. They think that concrete just gets strong, and it doesn't always do that. It's at a different rates depending on the amount of time that it's been sitting and the temperature it's attained. So we're going to briefly go through that. So the guidelines, if they are publicized, they're up on the web. However, each manual costs about, I'd say, $75. That's where they make their money. American Concrete Institute. The American Concrete Institute is international. So if you go to Bangladesh, you have to follow the same rules as you do here in Milwaukee. It is very unique. ACI was started in the 20s. And it's based on information going back to Thomas Edison. He was the first one, believe it or not, that did concrete houses. And a lot of the testing that he had done, they said, hey, you know what? This all makes sense as far as an engineer being able to design structures with concrete for different loads and for different sites. We should be able to test it and be able to come up with the mathematical formulas to be able to do that. That's where ACI came into play. So 318, you're going to see that a lot if you're in a commercial background. That also deals with if you're in a structure that's on bad soil. So if you're going to be doing foundations over pilings, or you're going to be doing foundations over a unique situation, 318 is basically for what is considered structural concrete. Okay, so that's where it's got to get a little beefed up because it's not a standard situation. ACI 530 is what is going to deal with any masonry. So if you're doing block foundations, you're going to deal with ACI 530. They're going to basically tell you how to lay the block, what you should be encountering, how much reinforcing, and for what situations, and then give you the mathematical formulas to deal with that. If your masons don't know what that is, you're in trouble. They also deal with veneers, okay? So all foundations all the way up, all masonry 530. 332, for most of you, and the MBA is usually single family, two family, 332 is what covers residential construction. They understand that things in residential construction are different than commercial. They understand that the structure that it's holding, that single family, two family, is fairly light in comparison to what you would see on a commercial application. So they've designed it appropriately. So when you want to deal with a simple house that's a light framing, 332 is where you need to be. Uh-oh. I think the battery's dead. We'll just do it that way. So, support live and dead loads above. Roof trusses have made things a lot more difficult. They have specific load paths that have to come down, and you have to make sure that they end up carrying down the foundation. One load path that most of you have experienced is in the garage. You have the giant header above the garage door. It comes down usually on 3 studs down to the foundation. Okay, and now on each side, and yes, I was part of this, but I tried to make it simplified, is the shear wall stuff. You have all of the shear wall stuff when it's less than 2 feet on each side that has to be put together and bolted and strapped to the foundation. Okay, well, when the excavator comes and digs, there's what we call a jump, or the footing steps, whether it's a masonry block foundation or a concrete foundation. Okay, well, if that load comes in between where the lintel has to carry that has to be designed for that. Almost no plans account for that because they don't know where that jump is going to be. So as you guys go out in the field and builders and so on and so forth, you need to make sure that your foundation contractor adds the appropriate steel if it's a concrete foundation, and if it's a block foundation, he'll need to add steel to that footing to be able to span that load now to either rest on that 4-foot wall footing or on the deeper foundation for the basement footing. And what we're seeing now is a lot of more simplified plans. It's cracking there, and then over time it's shifting because there is no fill, there is no support underneath there, so it has to be spanned. Normal ACI 332 will say on a normal jump where there isn't a point load, you need 2 additional pieces of steel and a poured concrete foundation, and if you go to ACI 530, there'll be additional rebar in that lintel that has to go there. But that's if there is no load. If you have a load, now it has to go to 5 pieces of steel with number 3 bar every 12 inches, and it has to be a lintel. And that's not happening for the majority of the basements, and that's going to create a problem, especially when we get more, that we're adding to the loads by adding the cement siding, the trusses are bringing down more weight, so on and so forth. So that is a critical thing. That happens throughout the house, and you need to kind of keep that in mind as you're going. Resist backfill soil pressures. I'll have another slide that we'll go over that'll be able to amplify that and picture that a little better, and keep bulk water out. The waterproofing and damp proofing systems are Band-Aids. The foundation, the concrete foundation or the block foundation, if done correctly, should be able to keep water out. Okay, and we're going to discuss that as we move on. But don't rely on the waterproofing and the damp proofing to do that if the foundation is poor. So this is a little bit about the loads. Windows. We're getting a lot of egress windows put in the basements. This has been coming, the International Residential Code has addressed this probably 10 years back, and they've required for every house to have an egress system in the house. Okay? We fought that here. Basically because that would add probably an additional $2,000, $2,500 to the cost of a house for no reason, especially if the homeowner doesn't want it. So, however, if you put the window down, then there's a special detail for what steel needs to go above the window. That needs to be put on the plans. Don't assume that the contractor is going to do it. ACI 332 has that in it. It should be 2 pieces of rebar that are going to go over the window, and then you see the diagonal pieces. They need to come down, and that reduces the chance of it cracking above the window. And then it is going to crack below the window. There should be control joints that get cut in on one side or the other of the window, depending on where the placement of the window is. And that, wherever you put a control joint, should have a water stop because it's going to crack and you don't want it to leak. So the backfill soil pressures. We're going to talk about soil and that, and this will make a little more sense as we go. The top example, if it's a 45 pounds per cubic foot soil, so that would be like sand and gravel. Okay, so if you build out in Genesee, by the time you get down 9 feet, that foundation at the bottom is going to have to resist 5,760 pounds. Because every time you add that 45 pounds, it's stacking on top of itself. Sand and gravel doesn't retain a lot of water. It's pretty much going to be that 45, whether it's a wet day like today or a dry day. So that isn't going to change much. So if you're out, the foundation you build in Madison and Genesee, going to be a completely different foundation than you build out in Mequon or Oak Creek or Franklin. 60 PCF soils, you can see it's almost a 2,000 pound difference by the time you get down 9 feet. So the foundation now has to produce or be able to support 33% more pressure from backfill soils than the one you build out in Genesee. So this would be Pewaukee. As you get closer to Greenfield, those soils that are kind of got some clay mixed in, silty, these soils, when wet, will bump up to like an 80. So it's been such beautiful weather the last month. All these soils weigh a tremendous amount more. So the foundations need to have that in consideration. So when designing a foundation and when you're building that foundation, make sure you understand how that's going to fit in. 80 PCF soils and above, because I'm going to say above because we've encountered especially fill soils, okay, where they've brought in fill, compacted it. A lot of those soils may be heavier, especially when you have situations with all the rain and they're saturated. Now you can see it's almost doubled from what that 45 was. So the foundation you build in Mequon, Oak Creek, Franklin, City of Milwaukee, or in a fill situation, like we were talking about, we had done a project together out in Stoughton, and it was all junk. It was all bad soil. And the foundations had, in this case, they couldn't even build basements because it had to be 4-foot walls because they couldn't even design the foundation to support those soils. So you need to be aware that that's where your knowledge of the foundation comes in. The designers that design these homes have no clue. They just take a spec that they've already made for somebody else. They cut and paste it on the foundation plan, and that's it. So then they run into trouble, meaning you run into trouble 10 years down the road when it fails. So granular soils, like we talked about, that's going to drain well. So you should be able to notice that right away when you come up on site. Compressive or expansive soils, you can see, can weigh up to 120 pounds per cubic foot. How they got there was through the glaciers. When the glaciers stopped, kind of pushed those soils out to that range. You know, obviously, if you've been in the Kettle Moraine area and the hills and valleys, that was all where the glaciers kind of stopped. So that's a very unique situation we have here in southeastern Wisconsin versus other parts of the country. You go to northern Wisconsin, they have the same soils no matter where you go. You get to Madison, it's pretty much all sand when you get down 8 feet. You go to Illinois, those soils are very similar. They probably have 10 different soils. We have over 50 different soils. So you need to be able to pick up on what you're looking at when the excavation occurs. And that's another thing to keep in mind. The plans were drawn without really knowing what the soils were going to be. So unless somebody's really taken the time, done soil borings, taken that information from a soils engineer, said, hey, engineer my foundation for these soils, so on and so forth, it's probably never happened. So we see a lot of designers, they're not taking that into consideration. It falls on you guys or your foundation contractor to do that. This just breaks it down. This soil table is in the Uniform Dwelling Code Council book. This breaks it down into the maximum bearing capacity for the soil, and where that is at the base. So before you put footings on, they want a minimum of 2,000 pounds per square inch that it's going to be able to support, and that's where those loads come down. So you can find this table in there. I cheated, copied it, put it here so that you could see and kind of get a good feeling for what you might find. The soil symbols on the, for you looking that way, it would be on your left. That is the engineering term. So if you get an engineer soil report, that's the terms they're going to use. And then you can cross-reference to find how much bearing capacity and then what the drainage properties are. Those pictures are terrible as far as you can't really tell the difference, but those are examples. When you go out to the job sites, you got to be able to pick up right away what you're looking at. Fill soils, hard to tell, but there's a black line or a darker soil that comes through for use. that not only do you look at the excavation on the base, but you need to look at the cross section of the banks when you go to the excavation. The cross section of the banks are going to tell a story. You need to be able to read that story, whether it's drainage tile running through the wall or the different colors, because that'll tell you kind of what you're going to have to plan for and do and design for. So hard to tell with the projector, but there is a definite darker picture. And then if you go to the bank that's back there, there's a lot of rock, so that was filled in at some point in time during the subdivision construction, where they had actual regular aggregate, number ones and number twos, built into that soil that got compacted as they went and built up the site. So this foundation was in New Berlin. I was driving by and noticed that it had pushed in. They filled the wall that was here, connected from here to there, and that was the stoop. So the backfiller filled that in with the on-site soils. The wall was not designed for that, and it just came in. So the wall is buried underneath all of the soil. I just saw another one this spring where they backfilled too early because it was cold, and the whole wall came in, cracked on both sides, and that one fell in too, but that was a house wall. But in this case, the communication between the builder, the foundation contractor, and the backfiller, you need to have that communication. These were all wet. This was all backfilled when we had a lot of rain like we did. It was heavy soils, New Berlin, clay soils, saturated, heavy. The wall hadn't gained enough strength. They filled it. What should have happened, it probably would have been fine if they would have filled it with stone. So in ACI 332, and this table is what you would use to design the foundation, for the backfill soils and the height of the soil on the wall, this will tell you what the reinforcing should be. There's a similar diagram for which they pulled right out of ACI 530 for block foundations that is in the UDC. So they didn't put it, there's a lot of bickering back and forth about putting this in for the poured foundations, but they said because it's already in ACI 332, we're going to adopt that standard, and you can go to that and get it. So this is going to be up on the website. You'll be able to get these tables. But besides the type of backfill soil, you also have to know how high the soil goes. And that is important because it puts a surcharge on the wall. On a normal foundation wall, what holds the top in place is the floor joist. Otherwise, it would have to be designed as a retaining wall. And there are some walls in the foundation that need to be designed as a retaining wall that we've seen and now I've experienced because the designs are getting more elaborate. But if you don't want it designed as a retaining wall, then you need to know how high it is. And if it's got floor joists, then you can follow this chart and it'll tell you the size of the steel rebar and the spacing of the steel rebar. Similar table is for block foundations can be found. So you do the same thing. So if it's a 9-foot wall, that doesn't mean that it's a 9-foot wall. What that means is unbalanced fill height. So if you have a 9-foot wall and the grade is going to be at 12 inches down, then it's 8 feet of unbalanced fill. So that's how to read that chart. So this is a good picture, which comes right out of the Uniform Dwelling Code book. The important part on this is when they put steel reinforcement in, its location matters. So they call it the tension side of the face. So where the concrete is terrible under tension, but it's very good under compression. So if the backfill soil's on this side, the tension face is on the inside. That's where it's picking up all the load from the backfill pressure. So the steel needs to be 2 inches from the face. You can't just shove pieces of steel in and it do its job. So that's important. If you go on the job site and the foundation contractor hasn't put the steel in yet, hasn't wired it in, and he's just planning on shoving it in as he's going, make sure he's shoving it in towards the inside face. And those pieces, the vertical steel that goes from the top of the wall down, is what gives it strength for the backfill. Okay? The steel bars running horizontally do not add strength to the structure at all. Those are there to reduce cracking and reduce shrinkage. So if somebody says, yeah, I'm going to add steel to the poured wall, I'm just going to throw an extra roll of rebar around the basement, it's not going to add any strength. Okay? It's a ploy. The vertical ones will. So the vertical steel is the important part in a concrete foundation. It's the same with block foundations. The locations of the vertical steel that get grouted in and how close they are and where they're held. There's actual templates, they're plastic now, that will hold the steel in the cores of the block in the correct location, which again is towards the inside face of the foundation. Those need to be used before you put the grout in. Otherwise, it really isn't going to do anything, especially if the steel ends up against the outside face. When factoring in that unbalanced fill, not only do you factor in where the grade drops on the outside of the wall, so normally we're 8 inches down from the top of the wall is grade. You also have to subtract out the concrete floor. So the concrete floor does act and help the foundation in this respect because it's holding against that a lot heavier soil when it gets to the bottom of that foundation wall. So that detail is important. So you subtract out, if it's a 3-inch floor and an 8-inch backfill, then you can subtract out 11 inches from your total unbalanced fill height. That makes sense? So we talked a little bit about not designed as a retaining wall. The shear wall anchors have nothing to do with helping the foundation resist the backfill soil pressures. Shear wall anchors are dealing with the shear wall or the shear characteristics of the carpentry panels above. Okay, so however, a lot of those shear wall details will add anchor bolts or add the size of anchor bolts that will help as far as tighten up that diaphragm or that structure. But don't misinterpret that. I know that there is some discussion right now as far as the Simpson straps and what they're doing as far as structural and keeping that sill plate on. That does help, but it isn't as good as anchor bolts. So this is a little bit about, this would be a jump or a step. And we talked a little bit about that where there's 2 pieces of rebar over that jump or step. That jump or step cannot be more than 4 feet. Those of you that work in Franklin, that building inspector knows this. You will not get away with anything more than 48 inches. Believe me, he'll bust you on that, and you'll have to get engineering. You can go more than 48, but you'll have to significantly reinforce that wall or make it become a lintel to manage that. Okay? Now, if you have a point load that ends up on that, in between those 2 sections, you need to reinforce that. You cannot just, those 2 pieces of rebar aren't there to now help carry the load. And a lot of people have missed that and misinterpreted it. As far as steel in the openings, what we're seeing is we need to have the rebar underneath. That helps reduce the cracking. You need to have a control joint on one side. That's not on many people's plans. If you get a block foundation, they'll actually put a break in the block there. If you go to a commercial job site, they'll have that. Those are details that a lot of craftsmen that may not have gone through formal training don't understand, so you may have to kind of educate them on that or look for that. But it will crack whether it's block or poured on one side of the window or both if this detail is not done right, and then it probably will leak because the way we have things in Wisconsin is we top it off with aggregate or mulch or whatever. That all sinks, and then where we mounted that area well, it sinks in those corners, creates a funnel, and that's where all the water goes, is right in that window well, and if you have any cracks, that's where it's going to leak. I would say a good portion of any callbacks that we have is because we failed to do this detail correctly. You're just asking for water to get there, so the water's present. You got to make sure that you do the detail so it stays away. This is a quick detail on rebar. If you go to Menards, and I know it's a funny thing when we have the meetings at the state. There's a couple contractors or a couple building inspectors that sat on the council that were from the Eau Claire area. So they love to pick on Menards because Menards, how they get their cheap prices is a lot of times it's lower spec material. Okay, so with rebar, it's very similar to that. If you go to Menards, they'll have what's a grade 40 rebar. Okay, that's the lowest grade that you can get. What that means is when they pull on the rebar or they bend the rebar, it's going to be more brittle and it's going to break before it meets the engineering requirements that gets computed into all the formulas to make sure that your structure is working correctly. Okay, so if you go buy rebar at Menards, you throw it in the footing, it's not going to work as far as how it was designed. When it's spec'd out to have rebar in, it's spec'd out to have grade 60 or above. So grade 40 is about 20% cheaper than a grade 60 rebar. Those markings, see it says grade mark, and there's a 4, that's grade 40. If it has a 6, that would be grade 60. It'll also tell the bar size. Engineering for rebar works like this. When you put in your computation for how that member or structure is going to work, it's the amount or the weight of the rebar. It isn't the size. So, yeah, you'll want to know what the size of it. If it's a number 4, it's in eighths. So if it's number 4, it's 1/2 inch, 4/8. It's a number 5, it's 5/8. Number 6, it's 3/4. Okay? The engineers don't spell that out. They do at the end. But when they put their computation, they figure out what the weight of that number 4 rebar is at grade 60, and that's what goes into the computation. So you can, if you need 2 number 4 rebar in something, you can substitute a number 8 rebar for that because it weighs the same as the 2 number 4s. That makes sense? So if something requires number 7 rebar, you can do substitutions because it might mean the difference in labor costs. So number 8 rebar is extremely heavy. So if you have to put it in a very difficult place, it might be easier to use 2 number 4s in that situation. So keep that in mind as far as for bidding purposes, or you get something engineered and the engineer requires some very large rebar. It might be cheaper labor-wise and will reduce your estimates if you went with smaller rebar and more of it, maybe narrower spacing, okay? And it could work the other way too, but keep that in mind. There are alternates and options to work around this. So keeping the water out is part of the system. NBA standards do a great job of that. They spell out, look, if you have a water problem in your basement, first thing you need to do is make sure that all the stuff above is correct. So it's got to have gutters. Those need to be drained away. The grade needs to be down 8 inches and pitched appropriately. Otherwise, all bets are off. And that makes sense, because if you keep the bulk water away from the basement, it's not going to leak. Doesn't always happen. Those of you that are trying to build homes in Vernon, this is where this came from. They want you at least 18 inches above the seasonal groundwater. Okay? That is a great rule of thumb. I think in Vernon they've taken it way too far, but that's for a different discussion. You need to understand, we did a house on Mary Lane, and most of you that work out in Heartland probably know this house. It's on 3 lots. It's very large, probably bigger than any other house in the area. At the time, it was probably the first house in the subdivision. They have a retention pond in the back. They built a sport court in the middle of the basement. The heights are set by the city in this case. So they set all the footing heights. I think it was 2006 or 2007, we had a 400-year rain. Milwaukee flooded, 22 inches of rain in 2 days. Their sport court flooded. They were upset. Okay? They called me. You put the basement in, it's flooding. So I went there. And I said, okay, so what happened? Number one, sport courts need to have bigger crocks. You're a lot lower than and near the groundwater table. You need to have bigger pumps. All he had was a 28-inch, normal crock with a 1/4 horsepower sump. I says, where'd the water come from? I don't see any cracks in the foundation wall. And it was tough and dried besides. He says, oh, the water came over the crock and just kept flooding. I says, well, you need to put a bigger crock in, you need to put a bigger sump pump in. Well, didn't you do that? No. Okay. And then I says, that retention pond back there looks higher than where we're standing. Is that the case? Sure enough, the top of the retention pond was probably 3 feet higher than where the base of the sport court was. And that's all sand and gravel for those that know that area. It's very easy for that water to find a sand vein and work its way front and back. So when you're building in those areas, you need to keep in mind not only the retention pond, but also the inlets and outlets for the retention pond. We've had other situations where the outlet was higher than most of the basements in the area. We had that out in Pewaukee. A lot of those basements flooded. Engineers got involved. They had to add 2 feet of stone to the houses that were there and then put a new floor. They had to raise all the mechanicals, all because the outlet was wrong in the retention pond. Okay? So, not anybody's mistake, but keep in mind those things influence the foundation design. Topographical features, if you're building into a hill and all the water is headed towards the basement, not a good thing. Most everybody understands, however, I see it done incorrectly. Proper drainage systems, we're in a great turn of events here. There's a competitor for Formadrain. Formadrain improved the drainage system from the 3-inch drain tile that was normal. Now, finally, we have a competitor, which is Proform. If you haven't seen it, it's a great product. So what it's gotten the owners of Formadrain to do is get off their bum and innovate. So we're going to have some good innovation, and we're going to improve the efficiency of these designs. But you can improve by having a drain to daylight, have the proper sump systems like on the sport courts. Those things are important. Especially the other thing is on the walkouts. It is code now that on the inside of the walkout, you need to have 3-inch drain tile that continues that interior loop of the drainage system. Not everybody was doing that. Where that becomes a problem is on those full exposures, the water collects, and then it usually the full exposure part, when they backfill, it's backfilled with stone that collects all the water, and you end up with the water just sitting there, especially in a clay lot situation. So there's no way to get that water out. This way you can collect some of that water, get it to the sump system and get it out. Where we've seen the problem is on the exterior of these walkouts is in winter, that water's collected, the patio that they put outside to use their walkout heaves, they can't get out, they can't get in, and there's other issues that arise. You know, they have the beautiful cooking systems that they put in for outdoor living during the summer, and now those have failed. So those are, keep in mind that that drainage system works all the way around the foundation, especially if you create it as a moat and you have stone and stuff in a clay situation. Poured concrete walls, and I'm going to use those. Block walls are a little different because that's porous, and they want that water, there's a damp proofing system on the outside to stop the water from getting into the cores, but if they do, it should get into the cores, percolate down to the crossover drain tile and into the basement. So if that's done right, those aren't going to leak. For poured foundations, it's only going to leak through ties. Poor practices for pouring where there's a lot of honeycomb or improper consolidation, and cracks. Those are pictures of different ties. In Illinois, they require all the ties because a lot of the subcontractors use those type of ties and those type of forming systems. When they break those loose or move them, it creates a void. So they make them seal them off on the outside with some type of either mortar or asphaltic material so it doesn't leak. Most, and I would say 99%, use this flat tie system, which breaks back in the wall. If you break it when the concrete is strong enough, it's not going to leak. We talked a little bit about the Forma-Drain. And the good consolidate. Wherever you have honeycomb or where there's a lot of rocks that consolidate together and create where you don't see the cement paste anymore and there's a gap, that's usually due to laziness, okay? ACI, whether it's 318, 530 for block, 332, spells out exactly how that concrete is supposed to get compacted. And it needs to get compacted, and that's the right term, because you need to mix in that paste, which is the glue, around all the different aggregate. And the aggregate is different in size and type. So there's sand, there's a different sizes of stones because it all needs to bind and get together. So if it's not consolidated correctly, not only is it going to look ugly, but it's going to leak over time. The more water you put in the mix when you're pouring to make it easier to pour, that water leaves during the chemical process. The cement paste shrinks more when there's too much water, and that's where you're going to get the excessive cracking. So if you have outside a control joint, all concrete should have control joints in it, whether it's a poured wall or flat work. But if it cracks outside the control joint more than 2 or 3 spots, my guess is there either was a large temperature change or too much water in the concrete mix. And that you can, when you show up to the job sites and you see it just, I want to use the politically correct term, where it's more water than stone and paste, it's way over a 5 or a 6 inch slump, which is how we measure that, which I'll show you real quick. That's basic, you guys all know that. It's a good illustration of the Forma-Drain, proper way to put it in. It should be stoned inside and outside before the footing is poured. If it's not, we get situations like this where it's very wet, banks cave in, so on and so forth, especially in areas where there's a high concentration of silt, so West Bend area. That's gonna, if you don't have the stone there, that's gonna plug up the drainage system, which is your best defense for keeping water out, is the footing system. That's a typical standard layout. 3-inch drain tile, you have to have crossovers or bleeders every 8 feet. Form a drain or Proform, it's minimum. This is minimum. I don't agree with it, but it is the manufacturer's specifications. Is 2 4-inch crossovers. If you have an area, if this is out in Genesee, this is probably going to be adequate. If you're out in those 90 PCF or above soils, this is probably not going to suffice. You're probably going to have more water, and you got to add crossovers to move that water.
Do you make adjustments on your foundations per the soil?
Yeah. I recommend, and this is the way we do it, when the excavation is occurring, we go out, look at it. So we're looking at the soil type, we're looking at the water table, we're looking at those things, and then we adjust our design appropriately. And that is through experience and following up on all the engineering and talking to different engineers for those types and adjusting for that. And that includes not only adding steel, but also coming up with solutions for the drainage system. This is the most critical, is the drainage system. Then we worry about the structural part, so adding steel to the concrete and so on and so forth. So every week we have a situation where we encounter a problem that needs to find a solution, and then we come up with a solution. We have one right now where it's high water table, and we're trying to come up with solutions. It might be that we over excavate by 18 inches, fill it with stone, compact it so that the water gets below the footings in that case. And then we put a deeper crock in to keep the water table below the footings instead of trying to battle that water table. But that's a good question. Yes, absolutely. And as builders and expediters, that kind of falls also into you to work with your foundation contractor to build that in, because it is important.
That was my thought. These designers want no liability, and they're not stamping drawings. You give it to the foundation contractor. How much liability do you take on, or do you say, builder, you should go out and get it stamped by a structural engineer, or builder, you should have your own geotech do a soil inspection before the footing crew comes?
If we've come up with a solution that we feel very comfortable with, we'll take on the liability. For those of you that haven't worked with me in the past, Gary has, I put a plaque on the wall with my name and a serial number for that job. The reason I do that is because I'm proud, and I want that owner, if he has problems, to call me. So if I'm taking on the full responsibility, if I put that plaque on the wall, that's my name. You guys do the same for building. They're going to call you first, okay? So I will take on that responsibility. If I've worked out a solution in the past and it was very successful, and I do go back and check on those projects, yeah, we'll take on the responsibility. But we have run into situations that are beyond our scope, that do require more number crunching, more analysis, and then, yeah, we will ask the builder or the owner, look, we need them to come up with a solution.
Because you guys are not structural engineers.
No.
And how much faith do I put in your expediter? Or your foreman? Oh, it's fine, it'll be
Right, and a lot of times it's up to yeah, and that happens too, where they said, well, yeah, Mike, that's great. Okay, I feel more comfortable if I get this engineer or that expert. And I'm fine with that too, because then it takes the liability off of me.
Subdivisions and soils are getting worse.
Yes.
These subdivisions are being filled, and you've got layers of fill, and I don't know where the virgin shit is, you know?
No, totally. And in a lot of cases, those developers already have engineers on staff, or on call, and they'll be called right away. We have a couple subdivisions that, as it's being excavated, they're called and they show up on site to take a look at it. And that's probably a more prudent way to do it. That's a 4-inch crossover former drain type system. Notice the 2 pieces of rebar sticking out. When you stop and you can't meld the concrete together, it's gotten too strong. You need to have 2 pieces of rebar coming out to connect the 2 pieces of footing. A lot of people, that's common sense, but it doesn't always happen that way. This would be a situation up in West Bend. We were coming out of winter, got a lot of rain. All of the water in the yard, it had sunk around the house about 2 feet because it had been backfilled with frozen material. So it worked its way down, and that silt percolated all the way down into the drainage system. So it filled the former drain completely. So a lot of times when we encounter this type of soil, we'll recommend that they put filter fabric over the stone on the outside of the wall, and then this won't happen. And you should keep that in mind. That's very easy. The excavators have been doing that. It's not that expensive. Geosynthetic Industries is right here in Pewaukee. They sell the 3-foot wide fabric, lay it out over the stone, and then they could proceed backfilling, and you're protected. But the silty soils will create havoc, and you might not even know it. Luckily, we caught this one. Just dealing with stuff that corrupts. We do check the former drain even though it's a closed system. That's a good practice. Just because it was closed and you did the things on the front end right, it's not always the same contractor that did the foundation that does the flat work. The flat work contractor should still, even though he didn't put in the former drain, check the former drain. Okay, concrete cracks. I heard this on Tuesday in an arbitration hearing. The guy's response, there were 22 cracks in the foundation. His response, concrete cracks. Okay? That was his response. No control joints, only 1 row of horizontal steel, no vertical steel, but concrete cracks, and that's going to be just fine. And then the foundation is what brought the builder into arbitration. Okay? Need to have control joints. These are our forms laid out. We have the steel running horizontal, and you kind of see that in the picture. But the reason that this picture is here is you see the V's in the form. Whether you form it in or you cut it in, you need to have control joints about every 20 feet around the foundation. And where those joints are, that's where it's going to crack. The only way the water's going to get in is through cracks or leaky ties. Put a water stop in the wall. It's very inexpensive. It's an easy detail. It will save a ton of headaches. And then you don't have to spend money on waterproofing. If this detail is done correctly, you're not going to have issues with bulk water. Unless there's a high water tail or something else, but for the majority of it, this detail will save you on that. We talked about the proper consolidation. We do use mechanical vibrators. Most people in the industry use what's called a puddle stick, or they jam back and forth. If they're doing that, that's acceptable, but they need to do it. There are ways to do it correctly. The same with if you're using a vibrator, just because you're using a mechanical vibrator doesn't mean that it's done correctly. There's actual, they call it a cone of penetration. So the vibrator on the end actually whips around So it moves more concrete further towards the end. So you have to overlap those cones as you're moving the vibrator. So there is a definite skill to it. And that's why I said if you find a lot of honeycomb or some other things, it's probably due to improper consolidation. If you don't consolidate the concrete correctly, you will not get the concrete strength desired. That is improper consolidation. So to fix that, you got to chisel out all the exposed aggregate, fill that with an expanding concrete, not a mortar that's going to shrink, so that when you put it in there, it fills the gaps and expands and not shrinks. And then if you're pretty good about it, you'll create some brick pattern. Hopefully that looks similar to that so it doesn't stand out, because it will be a different color. A little bit about concrete. The guy on the bottom, when we talk about slump or how much water is in the mix design, they use a cone. And it's hard to see in that picture, but it's about this tall, comes down. You flip the cone over so the big part is on the top. You fill it with concrete. You fill up a third, and you jab it with a stick. There's a specific stick that you use. Fill up another third, do the same, fill up a third. Then you flip it over, jiggle it a little bit, pull it up. When you pull it up, then it's going to slump. That's why it's called a slump test. How much it droops is the measurement. So from the top of that original cone that you had set down to where it slumped is the measurement. So if you say, I have a 5-inch slump, when you pulled that cone off and it drooped, from the top of where the cone started to where it drooped is 5 inches. Okay? So the more water you put in, the more it's going to droop. The picture in the middle is probably like an 8-inch slump. So that's way too much water for the mix design. Part on the bottom where you can see it's stiffer looking, that's probably a 4-inch slump. So the less water, stronger the concrete. However, it's going to be harder to work with. So you're always battling with the contractor that's on site. He wants to make it as easy as possible. So there is this temptation to add water to make it easier. You can't have that. It will cut, for every 1 inch of concrete, 1 inch of slump additional that you add to the mix with water, it loses 100 pounds of strength. So it's essential that you maintain that slump.
Can you repeat that real quick? You said for every...
For every 1 inch of additional slump you lose 100 pounds of the design mix. So if you had ordered 3,000 pound concrete, and that 3,000 pound concrete was designed for a 4-inch slump, and you go to a 5-inch slump, it's not going to be 3,000 pounds anymore. It's going to be probably 2,900. And that leads me to the next thing. That's at 28 days. So this is a hard thing for people to understand. Concrete, they set a benchmark so that engineers have a specific number to plunk into their formulas when designing things, okay? And they picked 28 days as far as where they're going to measure concrete strength. That is not when it stops getting strong. It takes about 30 years, as long as it has moisture, to reach its ultimate strength, okay? So and how they do that is they don't test it in the field. So they're gonna take a test cylinder, you're gonna fill up cores, and they're usually 12 inches in diameter, sometimes 6, okay? ACI has a special specification to that. You fill them up, you do it just like the slump test, you have to compact it in lifts, and you do 3 samples per truck. Commercial, it's standard. Residential, nobody understands this, so nobody requires it. And this is important because you should, once in a while, to double check that you're getting what you're paying for, make this happen. But then they leave those sit for a day, and you have to maintain their temperature okay? And it's the concrete's temperature, not the ambient temperature. The internal concrete temperature, you have to maintain that at 60 degrees for 24 hours. Then they go to a lab with those 3 cylinders, and they're put into a bath of water that is 60 degrees. They break the first one at 7 days to see if it's on track, and then they'll break the next 2 at 28 days. So it's done in a lab, okay? And it's done with perfect consolidation and perfect situation. So when you get out in the field, you can do testing out in the field with core samples and some of those things. But if the other items, the slumps and the temperatures and stuff aren't maintained, you're not going to hit that design strength. So we just had a situation where I did core samples at 963 days. People didn't understand that I had to back out using different formulas and get it back to what it was on 28 days. Code requires that minimum strength for footings be 3,000 pounds per square inch, for walls 3,000, and for floors 3,000. That's the minimum, but that's at 28 days. So to find out what that concrete was in that wall, we had to back it out using time and maturity and so on and so forth to that 28 days. Lo and behold, it came out to 2,700 pounds. So at 28 days, it wasn't at what the owner paid for. So that's important that when you show up on the job site, that your contractor is following those specifications and creating that. Otherwise, you may be liable to.
What were those minimums again? I'm sorry.
I was cut the. So for every 1 inch, I was wrong. It's 200 psi. You also waste a quarter of the cement. So a lot of the old school was, let's pour with a 6-bag mix, okay? What they were referring to is 6 bags of cement for the stone and aggregate. And what that usually comes down to in today's terms with better engineering is a 4,000 pound mix is a 6-bag mix. So you're wasting, cement is what costs the most in concrete. So you just blew probably $10 a yard by adding another inch of slump. So by adding that water, that's where it hurts you. The big thing is in the for floors, decrease the resistance to de-icing attack. It's been a problem around here, whether it's driveways, garage floors, stoops, where the surface falls. By adding too much water, that's a huge, 20% is a lot to decrease, and it's only a matter of being managing the amount of water going in the concrete. There are other ways to increase workability or flowability. There's chemicals now that can be added to the mix design. We did the Extreme Home Makeover in Dundee, Wisconsin. We're the only one during that program that did a full basement, so a full 8-foot basement. Everybody else did frost walls because they couldn't, they were worried about getting it stripped fast enough and so on and so forth. What we did was we ran 8 bags of concrete, but then we used 2 different chemicals that Axum provided, and we hit 12,000 pounds per square inch in 7 days. They weren't able to break the 28-day cylinder because it broke the machine. So the machine broke before the test cylinder broke. We had it stripped within 3 hours after we poured it. Okay, so we've worked with those chemicals. You can get the chemical, and it'll actually make the mix design stronger. They are expensive, but worth it. So if the contractor's complaining about workability and that's why he has to add the water, he's full of shit. Okay? You're gonna edit that out?
I can.
But that's not an excuse. Need to do it right. Strengths and slumps. We're in the severe area, so it's more important in Wisconsin. Winter concrete. Time and temperature is what dictates how strong concrete can get. It's the internal temperature, not the ambient temperature. This is misunderstood. So we need to maintain 40 degrees for the concrete to continue to gain strength. When it goes below 40, it goes dormant. So when your contractor strips the forms and it's 20 degrees outside, give it a couple hours and that temperature of the concrete is below 40 degrees, it will not gain any more strength until it gets back above 40 degrees. So think about that for a minute. How many weeks do we have in January and February where it gains back enough strength? Not much, but yet we still backfill 7-10 days, okay? You're risking a lot. So we tend to leave the forms on a little longer. We blanket the wall so we get an initial strength before we pull those forms and blankets off to kind of protect ourselves. We also increase the concrete strength to gain that strength. But if you're not doing those things and you're still running at the minimums, there's a good chance of failure. And when it freezes, if it freezes before the concrete hits 500 psi, it will never get close to the design mix. So if you ordered 3,000 psi concrete, and that's at 28 days, but it freezes at 500 before it hits 500 pounds, you're going to lose 40% of that strength.
So if you tarp it, the concrete generates its own heat. How long does that generate its own heat to capture that?
And it's the internal heat. So it's an exothermic reaction, the chemical reaction of hydration. So it's giving off heat. So by blanketing it, you're maintaining or capturing that, okay? By getting it up to 90 degrees, underneath the tarps, we've gone to a thermal imaging camera that we shoot, and we've been testing the last year and a half. Works pretty cool. They're pretty cheap now. But you can see, and we check it to see what the temperatures are. They also now have monitors that can go in the concrete and bring that back. But now I can get to 2,000 pounds in 48 hours and be fairly comfortable with, even if they backfill at 10 days, I'm not going to risk anything.
What about additional bracing that you could do?
Oh, anything helps, absolutely, because that's, especially the longer the walls, the more susceptible it is to the weight of the backfill soil. So if you brace it instead of every 20 feet, you're every 8 feet, that's going to be huge. This was in a Newman subdivision that we had done some other projects in. The high of the day before this was stripped was 5 degrees. It went to 20 below that night. The only reason I took a photo of it was because I couldn't believe they were pouring. We had canceled operations. Our ready-mix suppliers thanked us. A different ready-mix supplier, there is a rule, ACI does not want concrete to travel more than 45 minutes. Concrete's perishable. So if the delivery, and that's why it's very specific as far as delivery plants and their locations, you have to use a delivery plant that's within 45 minutes of where it's batched. In this case, this was over an hour away, so the truck was on the road for over an hour. So you have a metal drum, it's 5 degrees. Yes, they heat the concrete, they heat the water, they heat the aggregate. It's all heated when it leaves the plant, and there's specific temperatures that has to be. For instance, in this case, at 5 degrees, it needs to be over 75 degrees Celsius or Fahrenheit when it's batched. Okay, so when it leaves the plant, it has to be 75. But in an hour, in a metal drum, it's going to lose a lot of heat. And then they poured it. They did blanket it. But they only blanketed they were only 6 foot wide, so they only got the top and a couple feet down each side. And then they stripped it the next day. This is the day after that. So they stripped on a Friday. This is Saturday morning. What you see are the crystals that have formed in the concrete. And so the water in the concrete itself froze. And the top has like a, and this is the projector obviously is more pixelized. So if you had the original picture, the top is shiny because that's all froze. And now it's dormant. They backfilled within 6 days. Okay? I don't know where it's at. This was in, I think, February. We had a very warm period in January, and then we had a week and a half of very cold, bitter cold. This was in that valley. So I'm assuming it's on the end. It's not one of our clients, so I'm not going to go trespass. But this is not good. So to protect your homeowners and to protect the industry, because this is going to probably be a problem, more prudence in what we're doing out in the field makes a difference. This is the last picture I've got. This is one we just completed. The basements we've encountered in probably the last 6 years some very sophisticated and complex problems that we've had to solve because there's a lot of loading. There's a lot of, in this case, this is a 12-foot high basement on a lake. So not only are we dealing with 12-foot high walls, and we've got an engineer for that, but then there was to keep that space that's all finished, to keep that space from being infiltrated with steel beams and stuff, then there's loads on all the pads and the beams. And then in the middle, this wall across the back, that's going to be a pool that is an infinity pool that drops over. So that wall had to be engineered to not only withstand the weight of the backfill, but also that the weight of the water and it moving. So just be aware and understand that we can't do like we have in the past and necessarily go business as usual when we get a plan. That number one, we have to go to the site, make sure that the soils are going to fit for a basic design. Number two, make sure that wherever the loads and stuff are, they're going to fall in correctly. And number three, in this case, this one also had a unique drainage situation because it picked up, there were drains up above, and make sure that the water is drained correctly and is not going to accumulate next to the foundation and cause a problem later. So that's what I have open for discussion. Oh, it must have been good.
I just have one question. We do the trade test, those cores.
Yes.
And it failed. What can be done? Because already it's poor, right?
Right, tear it out.
They make you tear it out, or you have.
You tear it out, or then more engineering has to happen. There are solutions similar to block walls. Block walls have solutions. There's a lot of foundation repair companies. What they do is they come in and you mount a steel post to the floor joist and you mount the steel post to the footing and you're adding reinforcing. So you can do that. But there's different solutions, but the probably the most prudent thing at that point in time, and usually becomes the most inexpensive, is to start over.
If you're gonna make the concrete sub pay for it though, you better have the concrete cylinders stored properly, handled properly, transported properly, and tested properly, because he's gonna fight you. What I see a lot is the concrete cylinders are not stored and handled properly, so the tests are for shit. Basically.
Yeah, but
Because just what Mike said, if you don't store those cylinders under the right conditions, you're not gonna get the right test results. I see it in commercial. That's why in commercial jobs, you'll see basically coolers on the job site, and those cylinders are put in heated coolers. So you just can't take a concrete cylinder and just leave it laying on the dirt.
Yeah, there's specific instructions that you can also do in-place testing. That's the first process if somebody thinks that there might be something suspect with the concrete. It's a hammer test that kind of looks like a Hilti gun, and it's a rebound, so it shoots metal, it's like a pin, and then how quickly it rebounds back. And then you have to calibrate that to a chart, and it'll tell you what the strength was. So we've been involved in that too, where the strength test didn't come back correctly after 7 days. And so then they said, well, we'll give you an opportunity to check it again, and we did, and they came out. But that was part of the cylinders were tested, they didn't keep them correctly, and then they were kept too cold, whereas on site, it was warmer. So we hit a higher strength on site. It also, the other mitigating circumstance was most of the concrete now doesn't just have cement. Cement is very expensive. Cement puts a lot of CO2 into the atmosphere, so there's a lot of pressure to reduce cement. We're in an area, Jones Island, takes the coal, and Oak Creek's power plant takes the coal, the fly ash byproduct from the coal, grinds it up and uses it as a cement substitute. However, the benefit of that is it sets slower and you'll get higher strengths. The bad part of it, it sets slower. So, and then they also use slag, which is when you do casting with metal or steel and iron ore. You do the casting and you pull the mold off, and there's what's left over. They'll beat that up, break it into a fine powder, and that's used. They call it a pozzolan. Anything that will react correctly is a pozzolan, and you'll use that. That will really increase the strength, but that really retards the setting. So depending on the mix design, that also will affect your design strengths.
How many builders in this room do concrete testing, cylinders?
I think some of the concrete companies come out and do it once in a while, but it's not often.
You're putting a lot of trust into the concrete sub. Now, Mike's company is fantastic, but he's not always low bid. So you got to be careful.
I get short story. Probably early 2000s, we were pouring with probably 6 different suppliers, and a lot of times there were 3 or 4 different suppliers poured each day. So for the heck of it, I said, look, I want to do 3 or 4 cylinders from this supplier, 3 or 4 from that, 3 or 4 from that, same day. We'll take them over to, now they're PSI or Dan Anderson, and let's get them broken. That was the biggest awakening that I had. I was not from, 2 of the suppliers one of the supplier was way over, one was about what I was paying for, and the other one was under. So we said, well, that could be just a misnomer, okay? So we're gonna do it again. So the next week, after we broke it, so we broke them at 7 days. Next week, did it again. Guess what? We did it with 2 other suppliers, plus that one that broke low. They broke low again. So it is, you will get cheated if you aren't checking. You know, trust but verify, I think was Ronald Reagan's phrase. You need to verify. That is an easy thing for the suppliers to skirt through.
That's a good point. Concrete mix designs are different from each plant. They put in different amounts of slag or
The fly ash, yeah.
fly ash. So even though you're ordering 3,000, you're not probably getting it.
So the concrete part of the foundation, whether it's footings or foundation walls, and the same with the block foundations, how they mix the mortar. You know, on a commercial site, they'll actually pre-mix the mortar. So all they've got to do is add water and mix it, and it's got to be mixed properly. There's a standard for that. But that won't test out correctly if it's not done correctly. On a residential site, they don't do that. They have bags of mortar and they mix that up, and it isn't followed as critically as it is on a commercial site. And there's a reason on a commercial site why they do that. So, those things are tremendous issues as far as making sure that it's done correctly.
What's your value on like Watchdog or something? Because I know you said the concrete walls won't leak, and almost sounds like you don't place as high of a value on that kind of wall protection.
So I think we're up to, since we started counting, 8,000 basements. I've had almost as many tough and dry basements leak as I do foundations without tough and dry on it. Now, it gets the liability off of me, and so I do, if the homeowner wants it, I'm absolutely comfortable selling it. We have a great partnership with one of the other trades, and they provide it for us, and they do a great job. And like I said, it's a great insurance policy for them. It's transferable, so they could sell it to the next owner, and if there is a problem, they'll cover it. But if I do the basement and I do the foundation correctly and go through these steps and make sure all the things are designed for, I'm fully confident that without the tough and dry, we're gonna be fine,
No matter what the soils are or anything.
no matter what the soils are. The only we did one out on Sawyer Road on Oconomowoc Lake that we built 3 feet below the water table. We used a different waterproofing system, but we tough and dried the walls and the exterior, and that one performed very well. I don't think I would have done it without doing that, because we were 3 feet below Oconomowoc Lake, and there was water there all the time. And he did not want a sump pump. That's the other thing. So no sump pump. This was an engineered system. So, and it's working fine.
Doesn't the code require something?
Not if it's engineered. Not my idea.
How about backfilling with stone? You recommend that sometimes in certain soils?
In certain soils, except I'm not a true believer as far as, to me, water always finds the path of least resistance. And so if you build a moat around your basement, that's where the water's going to collect. So if everything is clay and you top it with 12 inches of dirt, of clay, and you get a dry period where that clay shrinks and cracks accumulate in the soil, and then you get a heavy rain, that water is going to find its way to the stone, and then it's not going anywhere. It sits around the foundation. So, there's something else to keep in mind. Menominee Falls has this particular issue with stone backfill, where they want everyone to have stone. I disagree with that. I think having a good drainage base, 18 inches, 2 feet at the bottom, great idea, because when it gets to that point, then you have to get it to the drainage system and the sump pump system. But you want it to find its way away from that basement, and you don't want it to stand there and collect there. And any way that you can make sure it doesn't do that, that's your first, that's your raincoat, that's your first area of defense.
Does it take soil pressure off the foundation somewhat? Or-
It does, and that's where it's beneficial. But you can find good soils usually close by. Everybody's looking for places to take fill. That would be a better substitute, offer a little less resistance for the water than number one stone.
I have a policy that any lake we build on, I do a soils report. It's just, I need to do it. When you read through the soils report, the engineer that we use basically says he wants the house backfilled with stone. Even though, you know, what's out there, it's all sand and gravel, but they still come back to the stone. Is that just something that they're doing to?
Most of the engineer report, it's no different, I think on the structural side, I'll see, there's some engineers that design plans that'll say, I want all this additional rebar in the wall, but I might feel a lot more comfortable with less. It's what they feel comfortable with that they've known have worked in the past. So it's worked for them in the past, why should they change? It's not a, you know, they're not having problems, it's, you know, it's their liability, they put it out there. So I'm gonna follow what they're recommending. I don't, to me, I've run into more issues, you know, like the frost walls backfill with stone and seen problems with the water collecting there. And so through my experience, I found that it's not always prudent.
Concrete wall ties, do you seal when you break it off? Do you seal the outside?
No.
Not
Now,
needed? Not a best practice?
It's a great practice, because then you're covering, you're always gonna make sure that if somebody breaks, and the key is, if they try to snap that tie too early, before the concrete gains enough strength, you'll loosen that tie in the concrete and create a path for the water to go. So if you aren't confident in your staff that is doing that, that's a great insurance policy. And it's a great add-on item if you want to do that, and that's a great practice. I'm not going to stop anybody, because it's going to alleviate any chance of ties leaking.
Walls are usually stripped the day after, and it's just a hammer, band, it's broken off. Is that okay, adequate, so we should still tar that tie?
It's the time and maturity thing.
Okay.
So if it's 60 degrees out and the concrete temperature stayed in that 70-degree range, you're probably going to be fine breaking the tie off. If it didn't and it's kind of below that and you're stripping, you know, and you say next day, so you're talking, they may have poured it at 4 or 5 o'clock in the afternoon and they're there at 7 o'clock in the morning, so you're talking 13 hours, 14 hours. My guess is that's probably going to be too early if it's below, if the concrete temperature drops below that 60 degrees. It probably would have been more prudent to wait, or leave the ties and come back and break them if you're not going to do something with the ties.
What's your company's best practice at that then? Because you know.
We don't break the ties unless we check to make sure that it's strong enough. And we make that decision. We have a whiteboard. I make that decision in the morning. A lot of times we currently are leaving the forms on, even at this stage, at least 36 hours. And we still may not break the ties.
Plus, it's a daily routine you go through.
Yep. And it depends on, you know, what's going on for temperature.
Just one more question.
Sure.
You know a good time, you have to run your insulation board all the way to the top of the foundation now. To address the part of the insulation board that's above grade.
No.
And I know, I've seen different methods, and I was wondering if you've seen something.
This came up at the state. That was my argument for not having the foundation insulation all the way up. However, the state hands are tied because we have to meet certain energy code requirements that are federally mandated. Otherwise, each municipality loses money. So federal funds. So we have to meet the 2009 energy code. End of story. So we have to bring it up all the way. The fiber cement code doesn't work real good. The bond breaker or whatever they're using, which is, I've seen it aluminum and I've seen it plastic. Does not look very appealing. I have seen Menards has like a faux stone or brick pieces that can go on there and cover it. That works pretty good. There isn't a great solution, but we need to do it. That is where most of the energy loss is on the foundation, so it has to be done, whether it's done on the outside or done on the inside. And you would rather, because of lowering the dew point on the inside, you want the insulation on the outside in this climate. So just have to work around it. I'm hoping somebody is working on this. I don't have time to work on it, and that's not our expertise, so.
Where's concrete ready-mix cost going
Up.
these days?
What has happened in the marketplace was the two largest suppliers are Holcim and Lafarge. Holcim is Swedish, I think so, Swedish or something in France, and Lafarge is France, okay? They were 60 or 65% of the world's cement supplier. Somebody in their infinite wisdom said, you guys go ahead and merge. And they owned most of the actual plants that produce the concrete. You know, cement is the powder, concrete is the final product. They actually vertically integrated over the late 90s and early 2000s into each marketplace, buying up the suppliers. You know, it used to be Two's Concrete in Milwaukee was the big supplier here. They were bought out by Lafarge, and then subsidiaries then bought them out, and then Holcim bought them. Okay, so it went from Lafarge to somebody to Holcim, and then now it's Ozinga bought them. Okay, so what has happened is it's become a monopoly. We have no control over the concrete prices. So, and they've not minced words. They're planning on increasing and increasing and increasing until the marketplace won't, give when it gives in. So, as long as the home construction and infrastructure construction and commercial construction is doing fine, we will see concrete increases.
But no problems with supply or limitations on,
If they're getting pushback from pricing, I bet we will see similar situation like we did 2 years ago, where they will supposedly have a problem with their plant or something, and our supply will be reduced during the most critical point of the year. And that was 2 years ago. That's exactly what happened. They were getting pushback from pricing. And so then, it was August, September, and October.
Everybody's trying to get all the groups done.
Yep. And lo and behold, they got their, I think it was $10 a yard or what. They were shooting for 20, but they got 10 from pretty much everybody. And they moved the price increases that used to be April 1st, which made sense because that's when the construction season picked up, but they moved it to January 1st.
It's also going to take the heated concrete prices off, so it's going to.
Right. So it is an issue. Well, thank you very much.
thank you.
Thank you.
Have a great day. I hope it stops raining.
Yeah, the next 2 weeks looks horrible.
Yeah.